So here I'm using a more pipette to draw about 10 milliliters of water. I got too much water, so I'm going to drain some of the pipette. Then I read the measurement under the meniscus, which is the curve in the upper tension of a liquid caused by surface tension. I record the initial volume, which is 0.18 milliliters, and then I drain the water into a separate container. I stop before the water passes the 10 millimeter mark. Then I record the final volume, which is 9.79 milliliters.
As you can see, the final volume for trial 3C was 9.79 milliliters. To get the volume administered, we subtracted the final from the initial, which ended up being 9.61 milliliters. Final volume. Here Maggie is using an alternative way to measure volumated liquids. Instead, she is using a graduated cylinder. In prior videos, a Morse pipette was used.
Here I'm reading the volume at the meniscus, or the curve caused by surface tension in a liquid. You will estimate the measurement at 1 more tenth than is shown on the graduated cylinder to have a more precise measurement, which was 10.9 milliliters here.
Alright, so what Maggie described just a second ago was the meniscus in a pipette. And so right here we see the little curve right here, that's the meniscus. And where the bottom touches is where we're going to measure. So right here we see that it's at around 9.9, but we have to account for error. So we're going to say that it's around 9.92, 9.91. Here, solution is being transferred from the stock container to another vessel. Here I'm extracting 20% stock solution to be transferred to a volumated flask. This will be our control for finding the mass of the unknown. We are supposed to pour enough solution for the bottom of the meniscus to just touch the line. Bam!
Perfect.
So that's about 1.8.
Down to a certain temperature and then it stops, and then once it moves too much, it kicks in.
Alright, now I'm going to fill the rest of the flask up with water until it hits the 25 mark. To find the concentration of the dilution, we use a proportion with concentration and volume to find an unknown data value. Here, the 20% stock solution in water, the 21.58 is the first volume times 20%, which is the first concentration, equals 25 milliliters, which is the first volume, times X percent, which is the second concentration. We end up getting 17.264. That's our concentration percentage. Now we're properly disposing of excess liquids. Good job! Oh, look over here. She's helping clean up our station.